Welcome to KBTV, the channel with a difference.
What's up, y'all? It's your boy King Bryan for real. Keep it locked. King Bryan for real. Keep it locked. Okay guys, welcome to this section of the video where we try to summarize everything that we learned in the early part and solve our solution set. Now today we're looking at laws of indices, and based on laws of indices, these are the laws we must always remember. So let's move straight into our solution set. Now our solution set for today comprises of 7 problems. So let's get straight into it. Okay, so number 1 on our solution set says 3 to the 5n is equals to 27 to the n plus 1. Now what do we do here? Now in a problem like this, the first thing we do is to make both the bases common, so we can eliminate that and work with the powers. So how can we, or what can we do to make these two bases the same? So in working problem like these, there's a little way in which you can do it to make it simple for you. So now we have 3 and we have 27. We see clearly that we can have 3 to some power would give us 27. So how do we find 3 to what power gives us 27? Basically, it's back to grade school where we do some long division. Now, basically that would be something like this. We have 27 and we divide 27 and we divide by 2, so we use 3. 3, 9, continue, 3, dividing, what's the next we have? What's the solution? 3, 3, 1. So therefore, we can clearly see that 3 times 3 times 3 is equals to 27. This can be rewritten as 3, 1, 2, 3, 3 raised to the third power is equals to 27. So we can therefore go right ahead and substitute here. So with a statement, okay, therefore what? Therefore 3 to the 5n is equals to 3 to the third power, not forgetting this, times n plus 1. Everybody follow me so far? What we're doing is changing this to one common base, where we went over here and we see we could have gotten the same base as 3, so we went and simplify it, and then now we substitute it. So let us simplify now. We have both of the bases are the same, so what do? We can simplify the tops and then drop the base, or we can drop the base and simplify. Now for simplicity's sake, let us leave the base and simplify further before dropping the base. So therefore we will get 3 to the 5n is equals to 3 3n. 3 times n is 3n plus 3 times 1 is 3. So now we go right ahead and drop the base. When we drop the base, we end up with 5n is equals to 3n plus 3. Now this is pretty simple. The next step from here would be to group the n's and simplify. So based on laws of transposition, we transpose the formula to make n the subject. So what we do, we take this away and bring it over here, group the terms. So we have 5n, this is positive, it come over is negative, minus 3n is equals to 3. Now we can further simplify this. 5 minus 3 is 2. Very good. 2n is equals to 3. Therefore, what would n be? N would be equals to 3 upon 2. Or this can either further be broken down as n is equals to 2 1s 2 and 1 3 upon 2. So we write our little statement. Therefore our function 3 to the 5n equals to 27 to the n plus 1 shows n equals to 3 upon 2 or 1.5. And that's it. Problem solved. Moving on to number 2. Now, number 2. This one, it's a bit different from number 1, but once we remember our principles, they are the same. Basically, what we try to do is to break everything down to the simplest form, not troubling the powers. So basically what we will do, try to break this down to the simplest form, break this down, and then apply all of our necessary rules. Okay, so let's go. First, what we do, we break down 6. Now to the lowest common multiple, so to speak. So what can we break down 6 as? We can break down 6 as 2 by 3. 2 by 3 gives us 6. Likewise, we do the same for 10. What can we do with 10? We know 2 5s are 10. So we know 2 times 5 to give us 10. But we put back our power. We're doing nothing with the power. We're just breaking down the bases. So 5 is to the 1, so we just write back 5. All of this divided by 15. So 15. What can we do with 15? 3 5s is 15. So we know 3 by 5 is 15. And we leaving the power. Likewise, 20. What can we do with 20? Can anyone say what can we do with 20? Okay, we know 20. We can get 2 times 20. But we know 10 can also be broken down as 2 5. So we know that 2 times what? 2 times 2 that's 4, and 4 times 5, that's 20. And we put back our powers. Everybody clear so far? Hope we are. Okay, the next step would be to group all the like terms. So how we do, we group all our 2's, all our 3's, and all our 5's. So the first we have 2 times 2 cube, 2 to the third power, no more 2's, times next 3, no more 3's, times 5, that's 5 to the third power, times 5. So yes, the next step would basically be to group all our bases. So let's go. We have 2 to the 1 and 2 cube. So that would just be 1 plus 3 multiplied by our next 3. So we 3, there's only one 3 up there, times 5 is 5 to the 3 plus 1 is 5 to the 1, divided by 2, 3 plus 3, times 3, just 1 3, times 5 square plus 3. So we further simplify. So that will give us 2 to the 4th power times 3 times 5 to the 4th power divided by 2 to the 6th power times 3 square times 5 to the 5th power. Alright, so we further simplify where we group all like terms. So to dividing, the power subtract. So we have 2 4 minus 6 times 3 1 minus 2 times 5 4 minus 5. Moving forward, our next step would be to further simplify. So we have 2, 4 minus 6 would give us negative 2 times 3, 1 minus 2 would give us negative 1 times 5, okay, sorry, 3 to the negative 1 times 5, 4 minus 1 will give us 5 to the negative 1. So the next step will give us 1 upon 2 square times 1/3 times 1/5, correct? And that will be equals to, further simplify this, we have 1 upon 4 times 1 upon 3 times 1/5. That will give us, what that will give us, come on, I know you can do it, 1 upon 60. And there it goes. That is the solution for lucky number 2. And if we take a run back through it, we have, this is our problem. We broken it down, smallest piece. We group all the like terms. We simplify that. We further simplify. After we group, we simplify. Then we further went to simplify, applying our laws. We further went to simplify that, and we further simplify. keep applying our laws as we come down. And there it is, 1 upon 60. That's lucky number 2. Moving along to lucky. We're going to move pretty fast on this one because it's the same principle as the previous one. Or I will give you this one for homework. Now, based on the one that we worked previously, you guys should be able to find this one. So, work this one on your own and comment the answer in the comment section below. And who knows, some lucky person with a correct answer could be winning a prize. Who knows? Yeah, so number 4. Basically what we have to do is to break down all these to the simplest form. So let's go. Like we did with the long division in the previous question, I think it's number 1. Let's apply the same thing here. So we have 90. So we have 90, that will be divided by 2. Okay, not bad, you're not seeing. So yes, so we have 90 divided by 2 gives us 45. 45 divided by 3 gives us 15. 15 divided by 3 gives us 5. 5 divided by 5 gives us 1. So that tells us that 90 is equals to 2 times 3 times 3 times 5. So the next one would be 60. So we have 60. 60 divided by 2 gives us 30. Divided by 2 gives us 15. Divided by 3 gives us 5. Divided by 5 gives us 1. So you can say that 60 is equals to 2 times 2 times 3 times 5. So the next one would be 36. Let's go. 36. Hope you guys are understanding what I'm doing. Pretty simple, huh? 36 times 2 gives us 18. 18 divided by 2 gives us 9. 9 divided by 3 gives us 3. And 3 divided by 3 gives us 1. So 36 is equals to 2 times 2 times 3 times 3. So then we now go and substitute all of this back into our original function. We have here 90, which is 2 times 3 times 3 times 5 multiplied by, we have 5 cubed, so we leave that as it is. That cannot be broken down further, times 4. You know, we can have 2 2's give us 4. So moving along smoothly. Now 60, we substitute what we have. 60 is 2 times 2 times 3 times 5. But 60 is a square, so we put back the power. We're not troubling the power. Times 36. We know 36 is 2 times 2 times 3 times 3. 36 has no power, so it stays as is. So the next step would be to group the like terms. So let's go. 2. We have 1, 2. We have 3 2's. So times 2 times 2. 3's, we have 1, 2. We have 2 3's. So let's go. Multiply 3 times 3. Now 5. You have 2 5. 5 times 5 cubed. Do the same for the denominator. You have 2 square times 2 square times 2 times 2. Move to 3. You have 3 3's. So you have 3 square times 3 times 3 times 5 square. Alright, moving along pretty smoothly. Let's go. So now for the group. So we have 2. All of these are to the 1 power. So we have 2 to the 1 plus 2 to the 1 plus 2 to the 1. We're adding the power since we're multiplying based on our laws, times 3, 1 plus 1 times 5, 1 plus 3. Moving along pretty smoothly. So now we have 2, we have 2, 2, and we have 1, 1. So it can be 2 plus 2 plus 1 plus 1 times 3. We have 2, 1, 1. So we have 3, 2 plus 1 plus 1. And then our 5 plus 5 squared. So we further simplify this. We have 2 cubed times 3 square times 5 to the 4th power all over 2, 2, 4, 5, 6. 6 times 3, 2, 3, 4 times 5 squared. For to break this down, we're dividing, so the powers will subtract. Very good. 2, 3 minus 6 times 3, 2 minus 4 times 5, 4 minus 2. Further simplify this, we have 2 what? 2 to the minus 3 times 3 to the what? Minus 2, pretty good, times 5 squared. So now this can be further broken down as 1 upon, remember this from our law? If you don't remember, you can always head on over and refresh your memory and come back. Likewise, times 5 squared. Then now we can further break this down, simplify it. We will have 1, 2 cubed. We have 2 2's 4, 4 2's 8, 3 square gives us 3 3's 9, times 5 square gives us 5 5's 25. So we further go and simplify this. When you multiply all of this, what do we have? We have, come on, this is the same as 25 upon 1. So we have 25 upon 72, correct? So therefore this is equals to 25 upon 72. This is our answer. Moving on to the next one. Let's see what's in store for us. Looks a bit different, but same principle. Break down to your smallest base. What we have? You have 2 by 3 gives us 6. We're doing nothing with the power, so we put back our powers times 2x plus 1. Do the same with the denominator. 2 by 2 gives us 4. Put back our power times 3x minus 2. Now what do we do? What is our next step? Our next step would basically be to group the like terms. So let's go. 2x times 2x plus 1 times 3x divided by divided by what we have in here. We have 2x times 2x times 3x minus 2. So we've grouped the like terms. Now we have to further go grouping. So we group now. They're multiplying, so the powers will add. So what that gives us? That gives us 2x plus x plus 1 times 3 to the x. Now do the same with the denominator. What do we get there when we group that? We have 2x plus x times 3x minus 2. Now we can further simplify this. We have 2x plus x plus 1 gives us, gives us 2x plus 1 times 3x divided by 2. X plus x is 2x multiplied by 3x minus 2. Alright, so now what we do there, we further go and simplify. So they're dividing, so the powers will subtract, correct? So let's go. We have 2x plus 1, 2x plus 1, let's bracket this for simplicity's sake, minus 2x multiplied by 3x minus what? X minus 2. So then now we must further go to simplify this. So what do we do here? Alright, looking at this, pretty simple. Now this, what do we do here? Alright, just for those who don't know or are a bit confused, let me open a window. So if we have x to the minus x minus 2, basically what is happening here is that we have a minus 1 in front of this bracket. So if we have, okay, let me write that. This is the same as x minus 1 times x minus 2. So remember, in factorization, whatever is here, we multiply out the bracket. If we're trying to remove the bracket, so let's remove the bracket. We have x minus 1 times x will give us minus x. Minus 1 times 2 will give us plus 2. So we see clearly, to remove the brackets, we end up with this. Alright, so let's close our little window and head back to the question. So in simplifying, we have 2x plus 1 minus 2x. 2x plus 1 minus 2x will just leave us with 1. And well, we simplified this already. We see x minus x plus 2. Right? That will give us 2 to the 1 times x minus x will cancel out, so we just have 3 with 2. So 2 to the 1 power is 2, and 3 to the 3 square is 3 3s 9, and that would be 18. So therefore we can say this is equals to 18. This is our answer. So yes, let's go. This will be equals to 2 to the third power times, you're breaking down 6. 6 would be 2 3s. So we have 2 times 3 give us 6. We put back our power. 15 would be 3 5s. So we have 3 by 5. Put back our power. Since we're not touching our powers, times 5. Alright. Next step would be to group. So, okay, they're basically already grouped. So we continue grouping. For what we have 2, 3 plus negative 2, just bracketing for simplicity's sake, times 3 negative 2 divided by 3 negative 5 times 5 to the negative 5 plus 1. Right? Everybody with me up to there? Alright, let's further go and simplify. So that's what gives us 2. 3 plus negative 2 gives us 1 times 3 to the negative 2 divided by 3 to the negative 5 times negative 1 plus 1 gives us negative, this would be 5 to the negative 4. My bad. So yes, we have to go and simplify. This would give us 2. We don't have any more 2, so this would remain 2 to the 1. They're dividing, so they subtract. So we have 3 to the negative 2 minus a negative 5, right? Times, there's no 5 to the top. What we do, 5 to the 0 power, this is 1, minus the 4, since we're carrying it up, and so that will be minus a minus 4. Okay? Don't have a 5, but we're still resimplifying. So 5 to the 0 power give us 1, minus 5 to the negative 4. So let's go simplifying further. Have 2 to the 1 times 3 minus 2 minus negative 2 minus a negative 5 give us negative 2, negative 5. Negative and negative is positive, so it would basically be negative 2 plus 5. That will give us positive 3 times 0 minus a negative 4. That will give us negative and negative positive, so we end up with positive 4. So you can further simplify. 2 to the 1 power is 2. 3 3s 9, 9 3s 27. Likewise, 5 to the full power give us, come on, work that mental, let me hear you. Close enough, let's go. Yes, 625. So then now, before to simplify this, we know 2 times 27 would give us 54. 54 times 625. Yes, so when we multiply this out, plug that into your calculator, you end up with that's it for number 6. Let's get down to the basic principle and see where this leads. Alright, first thing we know, we break down the basis to the simplest term. Alright, since this is not governed by a product but rather a negative sign, you would leave this alone for now. So let's go. 8, we have 8. 2 2's 4, 4 2's 8. So we have 2 by 2 by 2. So we write back the power n plus 2, n plus 2, n plus 2. Minus our 6 times 2, 3n plus 2. All over 2 to the n, 4, 2 times 2. Write back our power, n plus 2, n plus 2. So the next step would be basically to group all the like terms. So let's go. We will group these. Since we have a minus sign here, we wouldn't bring this over, but we would leave this as it is for now. Simplify the bottom. So let's go. 2, 1x. We have n. So we're adding. Alright, let's go. We have n plus 2 plus n plus 2 plus n plus 2 minus 6 times 3 times 2 3n plus 2. Alright, divided by 2, n plus 2 plus n plus 2. Okay, then what we get next? We have 2, 1, 2, 3n. So we have 3n. And then we have 2 plus 2 plus 2 give you 2, 4. Give you 6 plus 6 minus 6 times 2 the 3n plus 2. Alright. Denominator will give us 1n, 2n, 3n. So you have 2 with the 3n plus 2, 4 plus 4. Now, since we have this negative sign, and we see that we can factor these two because they have certain things in common. So we go straight ahead and we factor the 2. So in factoring the 2, we look to see what is common. What is common between the 2 is, so we have 2 to the 3n plus 2 as being common. So we factor in. So this multiplied by something supposed to give us back what we have here. Alright, so let's go. 2. So we have the same base. The powers add. So we have, if we multiply this, the base will remain the same since it is indices, and the powers will add. The power would be 3n plus 2 plus 4. So 4 plus 2 is 6. So it gave us back this. Minus, we basically leave alone. Right? We just factor in this out. So what's next? So that's multiplied there. Alright? So basically what we're doing is grouping the 2. But in order for us to group this, we have to factor because of this negative 6. 2 to the 3n plus 4. So now After we factor, we further simplify. So what we will have, 2 to the 4 will give us 2 to the 4, 4 twos, 8, 8 twos. So that will be 16 minus 6 times 2 to the 3n plus 2 divided by 2 to the 3n plus 4. Alright? So, further simplify, that will give us 16 minus 6 will be 10 times 2 to the 3n plus 2 divided by 2 to the 3n plus 4. Now, what's the next step? The next step is to simplify this. Further group that. So what we have? We have 10 times 2 to the 3n plus 2 minus, since we're taking this up, 3n plus 4. So what we will have here, you have here 3n plus 2 minus 3n plus 4. 3n and 3n will cancel out. 2 minus 4 would leave us with a negative 2. So that will give us 10 times 2 to the negative 2. This can be rewritten as 10 times 1 upon 2 squared. Now 1 upon 2 squared is 10 times a quarter. Alright, if you don't know, that is what, we can just do it simple like this. 10 upon 1 times that gives us 2 1s 2, 2 5s 10. No, what I'm saying, 2 2s 4, 2 5s 10. So we have 5 1s, 5 upon 2. This is our answer. So let us go back. So here we have 5 upon 2. So let's go get over. This is our problem. We see we have something different here than usual, minus 6. So we leave that as it is. We cannot trouble that because that is married to this. So what we do, we break down the 8, leaving the minus 6. We can't trouble this. We break down our denominator. We group our like terms, but we cannot group all our 2's because of this. So what we do next? We simplify it. We still can't group our 2's because of the negative 6. So in order to get around this, what we do, we factor the 2. So we see that what is common between these, we have 2 to the 3n plus 2. That is common. So we factor it out. Now if we multiply this, we will end up with this same numerator. So we factor it out because we see we can get one from the other. So we have 2 to the 4. The bases will be the same and the powers will add. So you have 4 and 2 6. So we end up back with our 3n plus 6. So we further simplify this. We have 16 minus 6. And we further went to group this and simplify. And ta-da! 5 upon 2. So thank you guys. You've reached the end of solution set for laws of indices. Do remember to like, share, and subscribe for more. This is your boy King Bryan saying, I'm out.
Took my heart away from money, I ain't interested in fame, and I pray that never change. Ambition is priceless,